Hello everybody, in this video I will solve some problems related with the topics of this week. And let's start with the first problem. In this problem we want to find the maximum value of the given function, which is y times x to the 4. And here x and y are positive and also they are subject to the constraint function 2x plus y equals 10. Okay, we are looking for point or points xy, which makes the function f maximum but also satisfy the equation 2x plus y equals 10. So to do this, first of all, I will start with the function to be maximized, which is given function. And the constraint here is, as given in the problem, 2x plus y equals 10. And I will call it g of xy. And we know that in the Lagrange multiplier method, we have an equation. It contains gradients, and we have to solve this equation with the constraint function, which is here gradient f should equal to lambda times gradient g, and lambda is here it can be any scalar, and also g of xy equals 2x plus y equals 10 should be solved at the same time. Let's look at the first equation, this equation. And in this equation, we know that the gradient of f is f sub x comma f sub y, which means the first partial derivative of f with respect to x and the first partial derivative of f with respect to y equals lambda times, here I have lambda, g sub x and g sub y. And let's continue from here. And I know that if you look at this part, and derivative of this function with respect to x is 4yx cubed. And derivative of this function with respect to y is x to the 4 equals lambda times derivative of g with respect to x is 2 and derivative of g with respect to y is 1. So we have two equations from there and one equations from here. So the equations are 4yx cubed equals 2 lambda and x to the 4 equals lambda here, and also I have 2x plus y equals 10. So we have three different equations. And if you look at the first two, you can make a relation between them, because on the right hand side of these equations we have lambda and 2 lambda. So I will multiply this second equation with lambda and then equate it with the first equation. I have 4yx cubed equals 2 lambda and 2x to the 4 equals lambda here. Okay, 2 lambda, sorry. Then I have 4yx cubed equals 2x to the 4. Okay. I will take this term to this side, but before I will cancel these 2 and 4. So I have 2y to the x cubed minus x to the 4 equals 0. At the end, we have this. Common parentheses of x cubed, I have 2y minus x equals 0. So the result from here is x is 0 or x is 2y. So we have x, okay. We eliminate lambda here. We don't have to find lambda because we are looking for the point actually. Okay. If you need, you should calculate, you should find the lambda. But if you don't need, if you can eliminate the lambda, so you don't have to find it. If x is 0, okay, let's continue with the pencil. If x is 0, using 3, I have 0 plus y is 10, so y is 10. So the point is 0, 10. Okay. If x is 2y, again using 3, I have 4y plus y is 10, which means 5y is 10. So y is 2. So if y is 2, x is, because 2y is 4, so the point is 4, 2. Okay, now so it's time to calculate our function at these points and decide the maximum value. Okay, so I have 2 points, 0, 10, and 4, 2. F of 0, 10 equals, if you substitute 0 and 10 to the 4 here, you will obtain 0. And f of 4, 2 is 4 times 2 to the 4, which means 4 times 16, which is 5. I have 4 times 16, which is 27, I guess, right? 4 times, 2 times 4 to the 4, which is 512. So if you compare the results, maximum value is 512. Okay, so the maximum value of this function with the constraint 2x plus y is 10 is 512. So let's continue with the second problem. In this problem, I just want to find numbers x and y such that their product is maximum and at the same time they satisfy the equations x squared plus 36y squared equals 72. Okay, so first of all, I will write the function to be maximized here. Because we want to find the maximum product, function will be f of xy, x times y, okay? And the constraint function here, the constraint is given as g of xy equals x squared plus 36y squared is 72. Okay, so we have the function to be maximized, and we have constraint function. So it's time to write the Lagrange equations. Gradient f equals lambda times gradient g and the constraint. From here we have first partial derivative of f and first partial derivative of f with respect to x and y equals lambda times partial derivatives of g with respect to x and y we have. So let's calculate f sub x and f sub y. Here the partial derivative of this multiplication with respect to x is y and with respect to y is x. And here the derivative with respect to x is 2x and derivative with respect to y is 72y. So we have the following equation. Okay, at the end, equations are y equals 2x lambda and x equals 72y lambda, and also I have x squared plus 36y squared equals 72. Okay, so first of all I have three equations, of course. We should be careful about this. Here lambda cannot be equal to 0. Why? Because if lambda is 0, if lambda equals 0, then y is 0 and x is 0. But 0 squared plus 36 times 0 squared is 0, which is not equal to 72. Okay, so because of that, lambda cannot be equal to 0. Okay, this is really good, because if lambda cannot be equal to 0, I can eliminate lambda here directly by dividing the first equation with the second one, or I can do it like that. Lambda equals, again here you should be careful about that, 2x over y. I can divide each side y with y, because if y is 0, then because lambda cannot be 0, x should be 0. 0 squared plus 0 squared, again 72. So we have 0 equals 72 here, so this can't be happen. So y cannot be equal to 0 and x cannot be equal to 0. Again, if x is 0, because lambda is not 0, y should be 0. 0 plus 0 squared is 72, not true. So I can divide each side with y. Okay, and also this comes from 1. And from 2 I have lambda equals x over 72y. Again, because sorry, y, this should be y over, let me write it one more time, y over 2x, so sorry. And here lambda equals x over 72y. Again, as I said, y is not 0 and x is not 0, we can divide. So from 2, so I know what is lambda and I know what is lambda here, so I can equate them. Lambda equals y over 2x equals x over 72y, which means 2x squared equals 72y squared. I have x squared equals 36y squared. Okay, this is really nice because I can use this result in the third equation by 3. I have this x squared, because x squared equals 36 y squared, I just substituted here. I have 72y squared equals 72, so y squared equals 1, which means y equals minus 1 or y equals 1 here. Okay. So now it's time to find x. I will use this result to do this. So x squared equals 36. It doesn't matter minus or plus because I have a square here. So minus or plus 1 squared is 1. I have 36. So x is 6 or x is minus 6. Which means we have 4 different points here, right? So let's write these points. Okay. I have this. When y is minus 1, we have 2 possibilities. Points are I have 6, 1, minus 1 or 6, 1. Okay. And also when y is 1, again we have 2 possibilities, 6, 1 or minus 6, 1. So we have 4 different possibilities. And to decide what is the maximum or minimum, I will just substitute these function numbers in my function, in the multiplication function, and decide the maximum value. Because f of xy equals x times y, we are looking for the maximum product. F of 6 minus 1 is minus 6. F of 6, 1 is 6. F of, I'm sorry, there should be a problem here. This should be minus 6 minus 1. Minus 6 minus 1 because y is minus 1. X is minus 6 here, okay? 6 minus 1 is 6. And f of minus 6, 1 is minus 6. We have the values of function at these points, so I can conclude that the maximum value of f, the maximum product here actually is 6. I can write it like that, the maximum product of x and y which satisfy x squared plus 36y squared equals 72 is f of minus 6 minus 1 equals f of 6, 1 equals 6. Okay, it happens at the points minus 6 minus 1 and 6, 1. So this is the maximum value of the maximum product of the function which have to numbers which have to satisfy this equation. Okay, so let's move on to the next problem. Okay, I just want to find the maximum value of the function. For this time we have again multiplication, but multiplication of 3 numbers here. So we are dealing with functions of 3 variables and we are on the space. And we have a constraint function again. So let's start with the We know what is the function to be maximized. This is the function to be maximized here, and it is directly given in the question that this is the constraint function. So I will define here this as g of x, y, z, okay? Then the gradient, because of the Lagrange multipliers idea, gradient f should be equal to lambda times gradient g of x, y, z here. And we know that g of x, y, z should be equal to 5x plus 2y plus z squared, 25. Okay, so let's try to calculate the first of all gradients. Here I have yz, this is the first partial derivative with respect to x, and xz and xy equals lambda times derivative of this function with respect to x is 5, then 2 and 2z. Okay, so I have 5 lambda in the first component, 2 lambda in the second component, and 2z lambda in the third component. So the equations are yz equals 5 lambda, xz equals 2 lambda, xy equals 2z lambda, and 5x plus 2y plus z squared is 25. We have 4 different equations, and we want to find x, y, z, and lambda satisfy these equations at the same time. So first of all, I start with the multiplying first, second, and third equation with x, y, and z respectively. Okay, why? Because if I do this, I have x, y, z equals 5x lambda, x, y, z equals 2y lambda, and x, y, z equals 2z squared lambda here. Okay, so and the left hand sides are equal, so it means here I have 5x lambda equals 2y lambda equals 2z squared lambda. Okay, first of all I have this, and here we have two possibilities. If lambda is 0, we have 0, 0, 0. So this equation is satisfied. But if lambda is different from 0, we can obtain 5x equals 2y equals 2z squared. And from there, we can obtain a point. So let's start with the first case. If lambda is different from 0, then I can cancel lambdas here. I have 5x equals 2y equals 2z squared, right? And by substituting these in the fourth equation here, because 5x is 2z squared, I will write it here 2z squared. 2y is 2z squared, and z squared, I have 5z squared equals 25, so z squared is 5, which means z equals minus square root of 5 or z equals square root of 5. Okay, so the points will be obtained using these equalities. If z is minus square root of 5, then 5x equals 2 times minus square root of 5 square, which means I have 5x equals 5 times 2, so x is 2. Okay. And I have 2y equals 2 times minus square root of 5 squared, 2 can be cancelled, so y is 5. So it doesn't matter if z is plus 5. Again, I will obtain plus 5, and square root of 5 square will be 5. So again, I will obtain x is 2. And the square of the square root of 5, because I have plus square root of 5 for this time, again 5. So we have 2 points here. Two, 5 minus square root of 5, and 2, 5 square root of 5 are the points. Okay, so what if what if lambda is 0? If lambda is 0, from first, third and second equation, we will have following results. y times z is 0, right? Here. Lambda is 0, yz 0, xz 0, xy 0. Okay. Yz 0, xz 0, and xy 0. Here, if y is yz 0, y equals 0 or z equals 0, right? Here x equals 0 or z equals 0, and x equals 0 or y equals 0 here, right? So let's call this case 5, 6, and 7, and I will analyze these cases separately here. In the fifth case, if y equals 0, okay, then this equation is directly 0, and here xy equals 0 directly, right? And this directly satisfied, but to obtain xz equals 0, to have xz equals 0, we have x is 0 or z is 0 here. Okay, so it means when y is 0, at the same time x should be 0 or z should be equal to 0. So I have when y equals 0 and x equals 0 case, and also when y equals 0 and z equals 0 case. Okay, in this case, to find we don't know z, and in this case we don't know x. If x and y 0 at the same time, z squared is 25. So z is minus or plus 5, and the points are 0, 0, minus 5, 0, 0, plus 5. Okay. And if y and z are 0 at the same time, for this time, this part's 0, this part's 0, so y is 2y equals 25 we have, so y is 25 over 2, which means I have 0, 25 over 2, 0. Okay, 3 more points from here. Okay, let's look at the other case. If z equals 0. For this time, if z equals 0, this equation, this equality holds directly, but to obtain, to have xy equals 0, for this time, we have x is 0 or y is 0. So we have again two cases, when z equals 0 and y equals 0, and when z equals 0 and x equals 0. Okay, so when z equals 0 and y equals 0 is the same case with that one, so we have just 1 point, 0, 25, 2 over 2, 0. If z and x is 0 at the same time, oh sorry, there is a problem here, so sorry. If y and z is 0, so I have 5x. This part is the solution of that. Okay. So solution of this. Z equals 0, x equals 0. Here z and y is 0. Here we have the same things. So in this case, we have 5x equals 25. So x is 5. So the point is 5, 0, 0, like in this case. Okay. So here again we have 5, 0, 0. Sorry for this. I will repeat everything one more time. Here y is 0, if y is 0, first here 5th and 7th equation directly satisfied. To have the 6th equality, xz be equal to x times z is 0, we have x is 0 or z is 0. So I have y is 0, x is 0, y is 0, z is 0. If y and z x 0 at the same time, if I substitute it in the first equation, then I will obtain z squared is 25. So z is minus or plus 5. We have 2 points here. When y is 0 and z is 0, it means for this time, y is 0, z is 0, we have 5x equals 25 here, 5x, follow this path, 5x equals 25, so x is 5, so the point is 5, 0, 0, okay. And here, z is, in this second case, we analyze this, right? And this. So when z is 0, in this part, this and this equation directly satisfied, but we should satisfy xy equals 0 also, so this means x is 0 or y is 0. When z is 0 and x is 0 here, when z is 0 and x is 0, we are here, because x and z is 0, 2y equals 25 here. Okay, I will write it here one more time, 2y equals 25, so y equals 25 over 2, so the point is 0, 25 over 2, 0. So erase this. Solution of this case is here. 5x is equals 25. When z and y is 0 at the same time, it turns to that case, so I can directly write the result directly here. Okay, so we have one more case, because x can be 0 also. When x is 0, here and here we have this equation and this equation directly satisfied, but we have one more equation here. So to have yz equals 0, y is 0 or z is 0 here. So when x is 0 and y is 0, when x is 0 and z is 0, what we have? When x is 0 and y is 0, we are on this case, the same case. So the points are 0, 0, minus 5 and 0, 0, plus 5. When x is 0 and z is 0, for this time we are on this case, right? And in this case, because x and z 0, we have 2y equals 25. So y is 25 over 2. So the point is 0, 25 over 2, 0. Okay. So I have too many points. From the first part, if lambda is different from 0, points are, let me write them. We have obtained that when lambda is different from 0, we have two different points here. 2, 5 minus square root of 5, 2, 5 square root of 5. And if lambda is 0, for this time we have first of all 0, 0 minus 5, 0, 0, 5, okay? And 5, 0, 0. Here 0, 0 minus 5, 0, 0, 5, 5, 0, 0. And also we have one more point, 0, 25 over 2 and 0. So we have 6 different points. If I calculate my function at these points, I will obtain this f of 2, 5 minus or plus square root of 5. Sorry, not minus or plus, minus square root of 5. Because the function is x times y times z, I have minus 10 square root of 5. F of 2, 5 plus square root of 5 is 10 square root of 5. and f of 0, 0 minus or plus 5 is 0. F of 5, 0, 0 is 0. And f of 0, 25 over 2, 0 is 0. Okay, so as you can see, we have just 3 different values, and the maximum value of f of x, y, z equals x times y times z is 10 square root of 5 subject to the constraint. What was the constraint function? It is 5x plus 2y plus z squared is 25. Okay. So this is the maximum value of the given function subject to the given constraint. Okay. Now we want to find the point on the intersection of the paraboloid that is x squared plus y squared and the plane 4x plus 3y is 5, and that is close to the origin. Actually, we are looking for the distance, the minimum distance, a point on the intersection of the intersection curve of these surfaces to the origin. So first of all, I will write the distance from a point to the origin is in the square root x minus 0 squared plus y minus 0 squared plus z minus 0 squared, right? So I have in the square root x squared plus y squared plus z squared. So to make calculations easier, function to be optimized, I will choose the function to be optimized as x squared plus y squared plus z squared. Okay, and the constraints here, we have 2 constraints. g1 of x, y, z equals z minus x squared minus y squared, and which is 0, and c2 g2 x, y, z equals 4x plus 3y equals 5. Okay, so we have function to be optimized, and we have 2 different constraint functions here. And we know that if you have 2 constraint functions, you should satisfy these equations. Gradient f equals lambda 1 gradient g1 plus lambda 2 gradient g2, and g1 equals 0, g2 equals 5 equations. Okay, let's find the gradients. First of all, here the gradient f will be 2x, 2y, 2z equals lambda 1 times gradient of g1 is minus 2x minus 2y plus 1, okay, plus lambda 2, gradient of g2 is 4, 3, and 0. So on this side we have this minus 2x lambda 1 plus 4 lambda 2 minus 2y lambda 1 plus 3 lambda 2 and lambda 1. So the equations are here, equations. Two x equals minus 2x lambda 1 plus 4 lambda 2, and 2y equals minus 2y lambda 1 plus 3 lambda 2, and I have 2z equals lambda 1. Also I have z minus x squared minus y squared is 0, and 4x plus 3y equals 5. We have 5 equations and 5 unknowns. So I will start with using the first 2 equations. Because there are lambda 2 here in the first and second equation, and I will leave lambda 2 alone and I will equate them to each other, okay, and then I will try to solve the obtained equation for lambda 1 x and y. So let's start with this. From 1 I have 2x plus 2x lambda 1 equals 4 lambda 2. So lambda 2 equals, in the common parentheses of 2x, plus 2x times 1 plus lambda 1 over 4. I can cancel 2's. X times 1 plus lambda 1 over 2 we have. Okay. And from 2, I have 2y plus 2y lambda 1 equals 3 lambda 2, which means lambda 2 equals 2y in the common parentheses of 2y, 1 plus lambda 1 over 3. Okay, so I have lambda 2 this and lambda 2 this, so I can equate them. X times 1 plus lambda 1 over 2 equals 2y 1 plus lambda 1 over 3. So I have 3x 1 plus lambda 1 equals 4y 1 plus lambda 1. I just take everything on one side. 3x 1 plus lambda 1 minus 4y 1 plus lambda 1 is 0. So at the end I have 3x minus 4y times 1 plus lambda 1 is 0. Okay, so it says that 3x equals 4y or lambda 1 equals minus 1. We have three cases here. And using these results and using the other equations here, we can get the result directly. So let's continue with the first case. If lambda 1 is minus 1. So if lambda is minus 1, lambda 1 is minus 1. From the third equation here, I can find z. Z equals minus 1 over 2. Okay, this is the first thing. So if z equals minus 1 over 2 here, I just want to find information about x and y using 4. I just substitute everything in 4. By 4, I have minus 1 over 2 minus x squared minus y squared is 0. Which means I have x squared plus y squared is minus 1 over 2. And this is not possible, right? This is impossible. So there is no point from this case. So let's continue with the second case. If 3x equals 4y. Okay. If 3x equals 4y. For this time, I can use fifth equation to obtain x and y. Okay, what I mean is that if 3x equals 4y by 5, I just substitute, let me write it here like that, x equals 4y over 3. I just substitute 4y over 3 here 4 times. 4y over 3 plus 3y equals 5, which means I have 16y over 9y over 3 equals 5. So 25y equals 15. So I have y equals 15 over 25, which means y equals 3 over 5. Okay. If y equals 3 over 5 here, then we can find this. X equals, just multiplied it 4 times 3 over 5. 4 over 3 times 3 over 5. So result is 4 over 5. Okay. So I know what is y and I know what is x. So it's time to find z here. And to do this, I will use fourth equation. Okay, by 4, I have z minus x is 4 over 5 and y is 3 over 5. So z equals 16 over 25 plus 9 over 25, which is 1. Okay, so we have only one point. The point is 4 over 5, 3 over 5, 1. So if you have just one point, this means this is the closest point to the origin. Okay, and the closest point to the origin is 4 over 5, 3 over 5, and 1. If you want to calculate the distance, you can calculate it. Distance is in the square root 4 over 5 squared plus 3 over 5 squared plus 1 squared. So I have square root of 2. So this is the shortest distance to the origin on the from the point on the intersection curve of the parabolate and the plane, given plane. So this is the end of this video. See you on next week.